Hey mathematicians, this is Mrs. Shopper coming to you with 7.4 parallel lines and proportional parts. We're going to continue to work with triangles and building on that. So here we go. Triangle proportionality theorem. This is the first thing I want you to get into your note cards. Okay. What it says is if one line is parallel to let's try it again, Shopper. If a line is parallel to one side of a triangle and intersects the other two sides, and it divides the segments into proportional lengths. So what that means is I've got two parallel sides, okay? That means that these sides are proportional. Okay, that's what we're talking about in here. And notice how it's set up too with the AB. Let me erase what I wrote. So AB is to BC. I drew my initial lines wrong. And AE is proportional to ED. Okay, so let's take a look at this triangle. All right, so I've got two parallel lines. Okay, and so what we're saying is that VS is to VR as SU is to UT. Okay, so I'm going to fill in what I know. VS is 3, VR is 8, SU is X, and UT is 12. Okay, so 3 times 12 is equal to 8x, so 36 equals 8x. So x is equal to 4.5. X is going to be 4.5. All right, now we also have the converse. So think back to when we talked about converse, right? We have statements. The converse flips the two parts. It flips the if and the then, okay? Flips the hypothesis and the conclusion. So what we're saying, if a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the third line is parallel. Okay, then we're saying the lines are parallel. So if these are proportional, then we can say that the two lines are parallel, right? So let's take a look at how this works. So DH is 18, HE is 36, DG is 1/2 GF. Well, I don't know what GF is, so I'm going to call it X. So this is going to be half X. We want to see if they're proportional. Is 1/2 X to X proportional to 18 to 36? So 36 times 1/2 X, is that equal to 18X? So 36, yep. So because 18X equals 18X, we can say that these lines are parallel because GH cuts them into proportional side lengths. Okay, cuts them proportionally. Let's look at the next one, the triangle mid-segment theorem. Whoops. Looks like I stopped sharing. Maybe not. Oops. A little bit of mistake here. Here we go. All right, so the triangle mid-segment theorem. All right, let's see what's going on with my screen here. Share it again. A little bit of tech difficulty, but that's all right. Nothing we can't handle. I hope your day is going well. That all your tech is working. That would be fantastic. This should be coming up any moment right now. It's coming. Oh, I've got mail. I'll have to check that out when I'm done with the video. Hopefully you're enjoying your time, your day. Let's go. Come on. Come on. Let's see. Still gonna be broadcasting. Let's cancel it and I'll try it one more time. If not, we'll go back to trying something else. Okay, let's get back into the meat. We all have tech difficulties, huh? And you're probably like, oh, now I somehow got kicked out of the meet? That's weird stuff. Let's try this again. I notice I've got like a little piece of hair that's sticking out. All right. Let's join on in. Hey, now there's 3 of me. What do you think of that? Let's go ahead and share this screen. Let's see if this works. Let's see. There we go. All right, let's go in here. There we go. Now you just see my emoji, you see my face, and you see my screen. Life is good. All right, we're back into business. Here we go. The mid-segment theorem. What that says is if JK and FG are parallel, which they indicate they are, and we know that the mid-segment of a triangle is parallel to the other side, then its length is half of it. So this length will be half of this length if it's the mid-segment. And what we look at is this tells us that K is the midpoint. This tells us that J is the midpoint. And if you have a segment parallel to the other side that connects your midpoints, then we know that it's going to be a mid-segment. So JK then is going to be half of whatever FG is. Let's take a look at this figure. All right, so D and E, or DE and EF, these are mid-segments. So if they're mid-segments, we know that to be true. Okay, now we have to find AB. Okay, so this is, so because BC is 18, we know that each of these side lengths are 9. Okay, we know that EF is a mid-segment, which means AF and FB are the same measurements. So because ED is 5, FB is 5, which makes AF 5. So the measurement of AB is 10. All right, proportional parts of parallel lines. So what we're saying here is that, oh my goodness, my hair. Okay, so proportional parts of parallel lines, we've got our parallel lines. What that means is that these are proportional, like AB is to BC as EF is to FG. Okay, those are all proportional. The congruent parts of parallel lines, so those are proportional, but now if these parts are congruent, we can then say that EF and FG are congruent. So one is dealing with proportionality, one of them is dealing with congruency, understanding the difference between them. But when you have parallel lines, then their side lengths are going to be proportional. So let's put this to work. Okay, so we have all of these sides, these roads right here are parallel. Okay. The figure shows the distance between city blocks. We need to find X. So in this case, we say that 13 is to 26 as 16 is to X. And so we solve that proportion. 16 times 26 is equal to 13X. And so then when we look at this, we've got 26 times 16 is 416 is equal to 13X. Divide by 13, 32 equals X. So X is 32. Okay. Find X and Y. Let's do one more. Okay, so because these two side lengths are congruent, we can then say that these are congruent. Okay, so we're saying that 3X minus 7 is equal to X plus 5. So we're going to have that 2X is equal to 12, X equals 6. And then we have 9Y minus 2 is equal to 6Y plus 4. Because these two are congruent, these two are then congruent. So 3Y equals 6, so Y equals 2. All right, thanks for your patience today with my tech difficulties. I hope your day goes well, and we look forward to seeing you soon. Take care. Bye-bye. Oops, I'm going to record now. It's just not ending. See you later. Bye-bye.